Okay, we are and live. Now we're live. Hello and good afternoon to all of you guys living in the Pacific time zone. Good evening to our friends over on East Side in New York. And I would say like a good night almost, right? We know it's gonna be like another like a long evening for all our European listeners. I'm not never sure exactly what time is in India. We always have like people to come from Indonesia. I have to check exactly what's time. Maybe you can tell us, let us know in the chat where it is. I can see we have people from San Francisco. Daniel is with us, and then hey, there is somebody from Canada. Cyrus is here, and Glauco from Rio de Janeiro, and there is someone from India. Bruce is from here, from Malibu. Hello, Bruce. Oh, Phil is with us again. Phil, good to see you, man. Good to see you that you're here. So happy to see you all guys tuning in. Oh my God, Nacho.
Gotcha.
Guys, we have Nacho with us, right? So Nacho, we're can't wait. Maybe we should have got you actually to dial into this call as well. So happy to see you. Laura Castelli. Oh my God, we know Laura, from the days of Scratch. So good to see you, Laura. Very good. And then let's see who else. There's more people from UK, and oh, there is someone from Echo Park, David Honor. And I have David. Hello, welcome. Good to see you. And Anastasia, ciao, Anastasia. Good to see you. And we have like someone as far as Topanga. Hello, very good to see you. And Ivan Vasquez from Mexico. My God, we have an amazing crowd today. I love it. I love it. So welcome to another Colorist Meetup, the live version, the streaming live from Los Angeles. And as you can see, I'm today with two fantastic guests, like people I really, really admire a lot. So this is Bill and Brandon from Colorfront, and hello, yay, very good. And they're like here today with us to really show us what they have been cooking, and actually this is probably one of the very few moments that we are going to be able to share like these things, because Colorfront is a very specific company. They are at the kind of one of the few companies that has stayed on the top end of feature film production, and they own that market, so they don't really need to do a lot of these events in order to promote their product. So you don't guys actually necessarily get a lot of info from them. Yet what they have been doing is absolutely mind blowing, and I can't wait to show you what has been happening. So if you have any questions, just please use the chat and, let us know. And, we will be happy to try to cover them. I haven't really filled up the whole kind of, presentation with too many things. But I really had the one thing which was my kind of personal desire. I have been doing this now for a while, and I'm just so like excited, to learn about the history of the eye, because how it all started, how things were happening. And I just couldn't resist this opportunity but to speak to Mr. Bill Feightner about it. And for all of you guys who don't know Bill, you have to understand that he was a color scientist and a CTO of eFilm, later Deluxe. And he is, probably one of the people who are most responsible for, shaping the eye in a way how to what it is today. And Bill, welcome, first of all.
Thank you.
Good to have you here. Brandon, hi. How's everything going in Santa Monica?
It's going great so far.
So far,
Thanks
very good. Good to see you there. So Bill, let's kind of start like a little bit with the history. I want to go back, just because, I'm certain that many of us, who haven't necessarily like been there from the day one as you are, have never really got to understand, what was going on at the beginning, and there is that story of Deakins doing his very first DI at the Kodak Cine site, But I understand that they couldn't quite do everything, and there wasn't necessary job where Deakins walked away being really excited about a digital technology. I believe there was because it was so early, like there were still some issues they were having, and then you came along and you kind of fixed some of these things. Can you help me understand what was exactly going on?
Yeah, I mean, part in fairness to that is that a lot of things were changing technically, and we made a decision at eFilm that we wouldn't get into the full DI, a full digital path. That's what, in other words, substituting for color timing the digital path until all the pieces were in place. So that was our history and starting with it. And if we think of it before, what had happened is, if we go back another 5 years before this happened, this was 2001 when we first entered. If you go back before that, people were doing effect sequences, sometimes digitizing film, but there was never the ability to do a full digital intermediate. In other words, replacing the lab color timing. And that was really the first marching orders. Let's replace it. And in fact, on this very first film, I'll start some slides in just a minute. On this very first film, it was done in parallel. There was a parallel lab timing going on, and daily prints from the lab timing, as well as our digital intermediate. And we started off just calling printer lights, our Dean Sumler, the DP on the job, would just look at our digital screen and say, oh, plus one red, minus one blue or something. And he'd see it on the screen. And then we would prove to everyone that when the film would come back the next day and a print was struck, that we would put that up, and lo and behold, that's that match. So that was the big thing, is closing that loop to make.
Wait. So I understand. So let me just kind of understand correctly. So what was happening on the very first DI is they would do a photochemical process that they would then scan and then modify that, but you couldn't really.
Well, no, not at all. They just, for safety reasons, they did a parallel photochemical process until we got through the first week or so, and everyone said, hey, this DI it really works. And then that was abandoned. So there was no more photochemical finish on the film. It was all done digitally. Brilliant. And then the first, what's very interesting, the familiar controls that were available in lab timing, we had the same controls digitally, red, blue, and green. And then as we progressed, our colorists showed, well, we don't have to just live with those controls. We can do other things with it, saturations. We can mask around areas and do all the things that only you can do digitally. And so that started entering the film. So it really had this progression from the old photochemical type of finishing within this film to utilize in all the tools available in the DI. In fact, if you think this is a good time, let me share the screen, and I can show you this little PowerPoint here.
Please. Brandon, I just want to say that you got compliments from Bruno, who said that you look handsome.
Yeah, there we are.
Oh, always good to hear and get a compliment from Bruno.
Okay, so everyone, I assume, sees that. So, okay, thank you, Colorist Meetup, blah, blah, blah. Okay.
Perfect. We can see that. Excellent. Go ahead.
Okay, so cool. So this is just a little slide. So this was the first end-to-end digital intermediate with no lab color timing. It was We Were Soldiers. And so that what that means is that the lab would just meet the printer aims that they normally meet, and the colors would come through, and that was no small feat. And this is just sort of a quick diagram that shows you know, what was going on there. And you know, we'd scan the film, we'd process the negative. We'd shoot the film, process the negative, scan it, and then we would do the digital intermediate. And what we were relying on, so we had the color controls here, but what we were relying on is the picture we saw on the digital projector. So we had a large Barco digital projector, and to make that match the lab, that took a lot of work. That was what was very innovative. We would take data from you know, what the film recorder was doing, the negative process and print process in the lab, and then also what actually happens with real projectors, and all that would go into this all this software analysis that we designed, and that would give us a display LUT that knew what the projector, how the projector worked, and basically the picture that we saw here would match the picture that we would get over here. So that was it. Basically, we were replacing you know, the lab timing with film. So great. And then of course we were able to use all the digital tools to alter the picture in ways that you ordinarily wouldn't be able to do photochemically, obviously, with just red, blue, and green printer lights. So this progressed for a while, and then at one point we said, wow, well, you know, the film doesn't have to look like a normal lab print. Sure, that's one thing. So we developed this concept of looks. So we said, well, we can design a look, and then we can make the film behave that way. So we would then use the same analysis, and then we would bend around how it was recorded onto the negative to make it match the digital projector. And that was a big turning point that, wow, we're not just captive to whatever a film print can do. We can do things beyond that, and let's make the film tag along. And then that led on, and then of course film was still the thing being captured. That led on to the fact, well, then we can take the output of digital projector and also deliver up here a you know, a digital projection along with the film, and the two would match. So that was that went on for a while, and then finally we get to today's workflow where, with a few exceptions, we're capturing everything digitally, and we're able to preview on set. We're able to do all our daily ZFX finishing and everything digitally. And then we can go back out to film, which is pretty much doesn't happen anymore. We can go out to all the different digital formats. So now you can see this is a modern list of things today, which is sort of the basis of this talk, that at all these different stages, the images match. In other words, when you sit down and a viewer looks at it, he's going to be able to rely on the display here, and then of course, all the deliverables are going to match in terms of preserving the creative intent. Sure, some displays have more dynamic range, and we can go deeper into the image, but the basic intent of the image is going to hold through. And that's sort of the essence of what we're going to talk about, is how is that possible? What do we do to do that?
But can I just interrupt you very quickly? Before we move on to that, I wanted to understand, so back in the day, you were actually working with the technology from Colorfront that they then sold to Autodesk, and that's what became Luster, isn't it? So the first systems...
This digital intermediate process, if we go all the way back to the very first slide I had here, this grading surface was Colorfront software, color correction software. And that was one of the things. We had an effort at eFilm to develop our own color correction. And we, at the NAB show back, I believe it was about 2000 or so, we met Colorfront, and they had a plugin at the time for discrete logic, which then became Autodesk, and for doing color correction. And we looked at it and they said, these guys know what we need. We need a color corrector that's based on film printer lights and can work that way, and as opposed to being a video color corrector. And so they were pioneering that. They were ahead of anyone else. No one else was really doing that, other than maybe some efforts at Cinesite, of course, in their own environment.
And is this then the same system that then Peter Doyle took to do the Lord of the Rings?
Yes, that same system went there. And what was done at that time with Colorfront is that it was a plug-in, and we had First Right, and so did Peter Doyle, on a standalone thing. And in fact, it was called Standalone Color Corrector at the time, SACC, is what everyone called it. And these were two proprietary programs that eFilm was using, and then of course Peter Doyle was using on Lord of the Rings to do this laboratory type of timing and within this environment. And then of course, the color correction system evolved. We worked intimately with Colorfront. I got to know Budapest very well.
That's an advantage.
We made multiple trips there. There's a lot of really good, positive collaboration, and we didn't have to. We were both talking the same language in terms of what this kind of a color corrector should be doing, not a video-based color corrector. And what's really interesting is that the run-of-the-mill color correction systems took more than 10 years. I think some of the other color correction systems out there to actually start adopting those kinds of principles. They were still inherently just video, some modifications to a video-based color corrector.
True. By the way, we're gonna have a Peter Doyle coming to our meetup soon. I will announce the dates as well, because and I will be talking to him also about these early days, because I'm just really, really curious. Yeah. And I want to dig a little bit deeper inside. Yeah. But Bill, let's now go a little forward. I kind of love the story that back 2001 you were super innovative and you were doing crazy stuff, and took many years, as you say, for anybody else to catch up what you were doing. But yes. I can't help but to actually see and kind of understand and feel that what you guys are doing today is pretty much the same. I mean, the amount of innovation that is coming out of Colorfront at the moment is just unbelievable. And one of the things that I remember, was that Colorfront was very early on describing and principles of color management, when most people didn't even understand why would you even consider color management, right? And today, I mean, what you have created is what I personally believe that, and I spoke to a few of my colleagues who are, also specific in color science, and we all agree that what Colorfront did with their stranded color management is really what we are all hoping ACES 2.0 is going to become one day, and you actually have it already now. And do you mind just maybe showing us this thing, because unless you guys are working with Colorfront, you would never know really what it is. And I know that this is a problem I have many times with people that when I try to explain what can be done, many people don't understand it. So do you mind just showing the audience what is it exactly, how this works, what's going on?
Yeah, that'd be a pleasure. I think it's obviously when you dive down into the technical details, it can be very complex, but overall conceptually it's pretty simple. And one of the first tenets of this is a single master. We make our decisions. This is how we want it to look, and then we expect that all the deliverables maintain that look within their limitations. As I was saying earlier, some display systems are smaller than others in terms of what they can show. So you want to still maintain the basic creative intent within that smaller display volume, and in the large displays that allow more range and colors, you take advantage of those. But the basic creative intent is there. So this is just a quick slide. It just shows that, we have to deliver things to all these different technologies, and we can't do a separate finish for every single display that there is. So that's one of the things, is how do we use technology to do that? So, we say preserving the creative intent. So this is something that every colorist is familiar with, is we sit down and we have a reference display, and we adjust things creatively until we say, that's my movie, that's my picture. So that's where we come up with this virtual, or this creative intent, and then all the deliverables and everything up and down the stream should match that, what we've ever done it. This can happen at multiple stages, and there can be, obviously it's an iterative process, but whether you're out on set and adjusting on a reference display, or back in, you may make some adjustments in dailies or in the final DI, or your DI colorist, or at the finishing colorist is also taking part in, while it's being shot, to define the look. But whatever you do, that needs to be preserved throughout the whole chain so that everybody sees it, and it survives all the deliverables. So, here's the typical workflow where we start with data coming from a camera. We call that scene referred, because it's just a digital signal that represents the light falling on the camera sensor. Very simple. Then we have transforms we put on that to map it into our reference display. And this is where we actually do the work on it, the artistic work. By the way, if this part is done properly, you shouldn't have to do any work to get a beautiful startup image. You shouldn't have to tweak for hours and stuff. A properly shot image will just come up, and when you use this system, will look really good. And then it's up to the artist to put his artistic intent on top of it to tell the story. And so anyway, we don't need a separate finish for each deliverable. Sometimes people have been doing that. Well, we're going to go to film, we're going to do one finish. We're going to go to TV, another finish. We're going to go to HDR, another finish, et cetera, et cetera. And no matter how hard you try and how many knobs you turn, it's really hard to get to make that match. And then also, that's very costly in terms of time and effort, especially as the number of displays and different kinds of displays keep growing. I mean, we often like to say, we're going to do an SDR and we're going to do an HDR, but in reality, it's not just one black and white line, thing there. There's this big gray area in between, where we have a range that's SDR and a range that we start calling HDR. So we have to be able to fit all these things. So some of the problems we end up with, say that the reference master display, which should be the king of all of them. In other words, it should show everything. If we have a delivery that's smaller, say in color space and dynamic range, scaling the image down, rolling off highlights, grading the image darker. No, we want to maintain the perceived colors and tonal relationships that were in that master display. So that's what this color management does. Same thing, it's the other way around.
And I think, sorry to interrupt, I think it's very important. It's very important to understand that this is an extremely difficult process, because, just changing values mathematically by far doesn't mean that this is how we perceive color. And
exactly.
And that perceptual aspect is the holy grail of good color management.
So I'll get into some of the mechanics of how that happens, but here's the same thing. And in other requirements is that all the way throughout the whole process, whether we're delivering into all these different flavors of deliverables, whether it's HDLG, HDR10, cinema, they should all, if you put all those displays together, you should maintain the creative intent. And if you did want to trim, say, you're doing your grade for a smaller home display, or you're doing it for a large cinema screen, you might tweak some things that are different, but you need to have the correct tools to do this with. Typical color correction tools are designed to add a creative art on top, not to do image translation. So there's different controls for trimming that if you have specific controls for this, things fall into place really quickly. Also, when you're doing your grading, you want to be able to preview different ranges. Here I'm just showing SDR and HDR, but in reality, there may be all sorts of different ones. So with this type of a system, we can say, okay, without doing anything on our, say our HDR monitor, what's it going to look like in the smaller SDR container? What is it going to look like in Rec 709 color space? What is it going to look like if we allow it to go out? And quite frankly, the basic creative intent survives. And this way is sort of a soft proofing as you're grading to be able to see the preview, how it's going to look. And in fact, this kind of preview can be done at any of the stages, be it out on set.
But Bill,
yeah.
I understand this now, but how did you solve this practically? Are you going to be able to show us give us a little bit what is really happening in practical terms?
Yeah. So
how would you guys?
So you made a very important comment earlier, and that was. We're not just doing mathematical adjustments. Doesn't necessarily mean that's what you're going to see. And that's really because the way our eyes work is that they aren't linear mathematical models. In fact, they're very, very complex models that have many, different dimensions. So, if you reduce the brightness, colors change, the saturation can change, the amount of colorfulness, hues actually change a little bit. So you have to compensate for all these. So the essence of this whole system is that we have a perceptual model that's been adapted to this kind of work that basically is an average of how the average person perceives things, whether when it's really bright and when it's really dark. And then this is applied to all the deliverables and applied to the startup image. And that's why things fall into place really well. So it's really what we call our Colorfront perceptual engine, which is, these perceptual transforms go between different nit levels, different color volumes to maintain the same look across different brightness levels and also in different viewing environments. There's a trim tool for whether it's going to be in a fully dark room. For example, if we're delivering for Dolby Cinema, which is, as pitch black as you can get inside of a room, then there's a different adaptation for ambient surround than for going into a normal cinema or going into a home. So these are some of the things that are put into that. Current industry output transforms that are available now don't address any of these things. They're just they each have their own unique look, and you have to sit there and do a separate finish for everything. So here's just a quick example of some things. This is comparing a Rec 709 output, and then here's how it would look if we had the two monitors side by side. In other words, we had a DCI-P3 projector, and so different intents, and ultimately we want to deliver things so that whatever our reference is, that across all the deliverables they match. Some of the things that go on, and I could spend hours on just talking about this part of the thing, is that this is a quick list of some of the better known things that happen when you
I have to say that this list is the reference list of the current state-of-the-art perceptual color research available in the world. So the Helmholtz Kohlrausch and Hunt effect and Bartelson-Brenman effect, these are all how come you're digging into this stuff? Where does this come from, Bill?
Well, there's lots of available data, and in fact, it keeps getting revised because people keep doing more research, and it's taking these data sets that are publicly available and integrating them and also adapting them to our particular use case, because this is a narrow use case, a specific use case that as opposed to, a lot of these are so that when you look at something lit up in a department store, that the color of the product or the clothes looks the same in one area as another. There's all sorts of things like this. Well, this is for a projected or emissive type of an image. And so they have to be adapted to work within our environment. But these are very important things. So this is just a quick slide on what is a perceptual transform. Pretty well described it, is that we know how the eye is going to respond to these different levels from the particular display, because each display will act differently because it may have different color primaries and things. The little curve at the right just shows, you know, here's a linear model of light, and this is sort of how our eye responds to light, that as it comes up at the very dark regions, we see a lot of difference, and then as it gets brighter and brighter, we see less and less difference. I just put this in here just to sort of demonstrate a point. This is sort of shows, well, what happens with surround lighting, you know, whether you're in a bright room or a dark room. And of course, there's variance on this puzzle here, but if you look on the left and the right, the squares are the same pixel value, but they look very, very different. If we put a perceptual correction on that, for one corrected for dark and then one corrected for a bright surround, they change, and now they're, you know, we're going from that to this. So now they appear close to one another. So these are the some of the examples of things that are done within the model. This is once again shows color, you know, brightness sensation with the amount of light, and as we see, it comes up very, very quick, and then brighter and brighter. So that just says that, you know, 200 nits is not twice. We don't see it as twice as bright. We only see it as slightly as bright. If we wanted something twice as bright, that's, you know, from 100 nits, say SDR, we have to go to 1,000 nits, roughly, not exactly, but roughly. It's more or less a logarithmic type of function, which all our
and it is actually the PQ curve is actually very close to the perceptual. You know, that this is why it's called perceptual quantizer, because this is the curve that was, you know, derived from, you know, measurement of how we respond to actually to light and to
in fact, it's very, very close. There are some modifications, and once again, it's been adapted for a specific use case for encoding to minimize errors, because the first thing you see is that we're going to allocate a lot of our bits. If we only have a fixed amount of bit depth, we want to allocate them where the eye is most sensitive, and then fewer and fewer required as it gets brighter. So
am I correct assuming that actually all of that research that you have just mentioned, and, you know, I'm so sorry that we can't cover more of that. I personally would want to like make a series with you, and anytime
maybe we should do that. Yes,
you know, anytime you want to do a training, please talk to me, because I think, you know, that it's a really necessity for our industries to start moving more into direction of perceptual color sciences. And, you know, it would be fascinating, you know, if you were to do this training further. But because we are limited to 1 hour now, we can't really go too deep into it, Bill. What I would
but at least we have an appreciation, and I think, I mean, you can spend, you know, a lot of time really going deep
but
into
you know,
things,
the fact is you have implemented this science and this research into your current products. And so mathematically, when you're making adaptations from one screen to another, you're not just using like some ACES transforms or whatever oddities, IDTs, but you are using your own source that is actually using much more advanced way of analyzing image and adapting it to the perceptual value rather than just a kind of, you know.
So it's a mathematical model, and yes, I mean, you may still want to do a trim for a theatrical release on a very, very large screen versus a smaller homes thing. So sure, but you ought to have the right tools, but it should be almost there. I mean, you shouldn't have to start over. And with this system, things fall in really quick. And then also the wake up image falls in quick. For example, here's just a quick little thing here. What we're seeing now are various camera outputs. So, you know, here is a red log 3GD10 output onto just going to the screen as it is. So it's a flat log image. Here's what comes out of an Arri camera. Here's what comes out of a Sony camera. But all of those should, if you just plug it in, this is, it should wake up with a beautiful look. And whether it's rendered to SDR as it is in this case, because we can't do HDR yet over Zoom, YouTube can, but someday maybe we'll try that for those who can have who have an HDR, and then we can do a lot more. But it just shows that things should plug in and fall in and look really well balanced and things, and then it's up to the colorist to make the creative choices how he wants to do. Also within the Colorfront engine is that we do have this default look. We call it the Colorfront master look, but there is a whole library full of different default looks. Here's one that's a softer look that is actually much more flattering for you know, face tone, so that gets used. here's one that's a traditional film look. There's a whole library, and these are based on, public data sets on how print film works. In fact, it's an average of quite a few of them because different trips through the lab come up differently. So anyway, within our system, you can then take these different palettes you want to work into or mix and match from one scene to other. You can change them, but no matter what camera it's coming from, we should wake up. In fact, we should be able to point an area and a red camera at the same scene. And you say, oh, this is the look I like. Well, we can also apply it to the, we're looking at, say, an area. We should also be able to apply it to a red or to a Sony, Canon, and end up with the same look. And that's part of the color management on the input. This whole system, as far as the transforming the camera data into a common working space, is based on ACES. That's what the original ACES was. Well, not really the original, but once we started coming out with digital cameras, that was one of the goalposts, is that all of the images come in, they get translated into a common color working space, so that we basically have two different cameras pointed at the same scene within the limits of each camera, within their range. We should produce the same digital values. And then, of course, the delivery side assures that we see this same look, whether we're reproducing it on a digital projector, or whether we're showing it on a Rec. 709 monitor, or whether we're showing it on an HDR display. We should have basically the same look. We'll just have more range to deal with. So people ask, well, that's great that you have color management, but the biggest problem with most public color management systems is that there's not end-to-end support. In other words, we should be able to preview things out on set. We should be able to preview.
And that's exactly, so Bill, this is exactly, I think, what I'm interested in now. I love this part, that you have explained to us to understand. Here is the problem that we have, and here is what we figured out, what it's necessary. But I, as a colorist now, I got so excited. I said, oh my God, look, somebody has, figured it out. How can I, guide my clients and explain to them that we could implement Colorfront color management in the production? And you're right. It's not just let me do it in the grading, because it's too late. We need to do it on set. And you know what? I need to have a machine room also be color managed, because when we start spitting out all the masters, I can't have a client walk in every second day to approve a master because it's looking slightly different, because we can't get our masters to look the same. So can you are you going to be able to show us really what happens? What's going to happen on set? What we're going to do when we grade? What we're going to do when we master?
Obviously, there's a lot of details to go into, but just a quick overview within the time constraints. So let's say we're on set and we want to properly view things. Well, Colorfront has worked, there are a number of solutions, but this is one that's having a lot of success, and Colorfront has worked with POM4 to integrate this same color management on set, where we can see various nit levels. If we have an HDR monitor on set, we can use that same monitor without touching it, leave it in HDR mode, and we can preview how it's going to look with Rec. 709 at 100 nits, how it's going to look at 1,000 nit deliverable, how it's going to look for any, in a 48 nit film deliverable. So all of that's controlled. POM4 has an interface that integrates the controls of Colorfront into its software so that it can produce it. Also, there are other solutions. There's also I'll show you later. Basically, what POM4 is doing, it's talking to a piece of hardware that sits out on set, which is basically the same Colorfront algorithms and transforms we've been talking about are integrated into a product from AGA called FSHDR, and then POM4 simply controls the parameters of it. Also shown here is a companion product, which I use all the time. Actually, it came out of our internal R&D. We need some way, if we're going to do all the color science, we need a way of analyzing it and really seeing what's going on. So this is showing also another product there, which is the
analyzer.
The analyzer.
I worked with a DP last year who said they didn't want to shoot without it.
Yeah. So that really works well. It's designed for working with all different net levels and things. So obviously we can go into detail. So okay, that covers that covers the on-set dailies and things, well, the Colorfront, we offer a product for dailies. That's our dailies. In fact, the most widely used dailies product is that. But for finishing, how do we carry this through to finishing? Traditionally, what we had to do is we get this far.
Sorry to interrupt. Sorry, 1 second. So if I'm using you know, this product with a live grade, then I can export your proprietary CFE format to OSD to your dailies platform. But what if I am not able to control the dailies because the production has signed a deal with the local Colombian post-production company that will be doing the dailies, and they don't want to pay for OSD? They're using whatever, you know, Scratch or, you know, whatever else. Is there any way I can still, you know, generate some LUTs and CDLs and somehow way for me to control the dailies on some third-party facility?
There could be, if you want to use a different dailies platform, you could use the dailies, whatever they're using, unlutted, so to speak, and substitute the FS-HDR, and they're available for rent or as well as for purchase from different people, in your output preview, and have the same advantages, and then you're just color grading with that platform, managing your dailies and things. The only thing is then if you want to deliver, you would have to then somehow publish or make a lookup table. And I'll get into some of that later, what we're supporting, some of the new workflows that are designed for that. So we'll go into that, if your system can't have the Colorfront software component running in it, there are new handshakes being proposed by the Academy, which is the common LUT format, which can be published from the Colorfront product. So we'll get into that so that you can. But if we're supporting on set with dailies, then we have this. The other thing is that the other tool that's used quite a bit in dailies for people who aren't using the Colorfront oftentimes is Resolve. So if we talk about that, there is a plugin that is coming very soon for Resolve, and basically it allows you to implement all the color management we have within Resolve and still use all the Resolve tools. And,
Bill, where can I sign up to go onto the beta list for that plugin, please?
Well, I guess we have some emails. Send us an email. This is gonna be first in just a limited beta, just to prove out everything, and then we'll figure out what the business case is. But yes, there's a lot of need for this, so we're very excited.
And what about the Filmlight products?
Filmlight, this may run. We haven't vetted it in it. This is running. This is an OFX plugin that utilizes the GPU power. So we will see how that works within the Filmlight environment. They also support OFX. We'll have to see what the performance is. But that's the first release is going to be for Resolve, and then also supporting Resolve on Windows, on Mac, as well as on Linux. So those are some things that, you know, each one of those is, you know, takes some separate support because the systems behave different. But anyway, that's where it's going. I've been working with this. I'm very excited about it. So that's coming soon. I'll get into this next thing a little bit. If we talk about, and this is what you were bringing up earlier, is what's the handshake between all these components? Traditionally, you know, somebody would make a show LUT or several show LUTs and then start sending around this show LUT around to all the different things. The problem with the show LUT, it's a fixed transform. It only takes one color space in, and it only serves one output color space, say to Rec 709. And if you wanted to go to something else, you'd have to have a completely different LUT. And they are large. So with our system, this is how we just take the parameters and transform them from what you have on set to dailies to finish, and then back again, because your finishing colors could be looking at something, iterating, and then send this small CFE file back. And you can see an example of it on the right. It's a human readable, editable file. If you wanted to adjust exposure or something, you can go in there and find where exposure is and edit it manually, but or use the software.
No,
but
I don't want to do that. This is like for the developers, kind of.
Yeah, but it's a JSON. human readable file,
Yeah.
and has all the transforms, and it's expandable as we add.
So
more.
what you're saying is that actually there is no more actual cube file. What you're using is just a set of parameters.
Yes, it's a parameter-based system. And the advantage of that, a cube file, it's fixed. So if you wanted to change, say, brightness, or you wanted to change the color tint slightly, you'd have to deliver a new cube file. This is, you load it in and you say, okay, that's where we were, let's change it. So it's you can knob and adjust things all along the way. There's nothing fixed, because it's just a file describing the mathematical transforms that are in the Colorfront engine, and you can keep iterating to your heart's content.
That's amazing. And that is really, you know, solving the biggest downfall of a 3D LUT we have. You know, as much as useful it is not changeable. It locks you in, and we want to sometimes be locked in, but when it doesn't work, there is nothing you can do to help it, if you know what I mean. Like, and you know, I'm not saying like, and then another thing as well is like, I've spoke to some colorists, and they're losing faith in LUT because they feel that they sometimes lose that image fidelity. Yeah,
you can't go beyond what the LUT does. So this is a parameter-based thing, or you can set it wherever you need to go. You're not limiting or hobbling anybody. So that's the thing. One of the things that, just a quick mention, is that all of this is also built, everything you've seen is built to work within the ACES framework. And that means that with ACES, it allows the transform that's called an LMT. So we can get the same results in an ACES pipeline as we get in the standalone Colorfront pipeline. In fact, I'm going to share my other screen in just a second and show you some examples of that.
So just to kind of reiterate one more time. So what you're saying is this: I work Colorfront color managed, but if my production has decided that we need to be ACES compatible, which is usually like on a studio level, you know, the decision is made, it's absolutely no problem for us, because it's easy. We can just move into the ACES pipeline, and we're going to maintain the same image fidelity and same look, more or less.
Yeah. So just really quick, I mean, it shows that we have the ACES CDL and LMT. So typically in ACES, you've got the CDL that you can apply, but if we use the LMT part and turn on the Colorfront engine, now this will match anything we would have done with a standalone Colorfront engine. And this is also a plugin in Resolve, so you can use the stock Resolve ACES workflow, and then just add the Colorfront LMT node to it, and you've got the same thing. This just shows what the node does. It's, instead of being a static LMT that sometimes people have published, this is a dynamic. It's parametric, so you can keep tweaking it. But if you want, within the ACES environment, you can publish a common LUT format, which is, people call it the ACES LUT, or CLF file. And so you can export that for those systems that don't have Colorfront technology incorporated, as long as they support the new ACES CLF file. So that's
so Bill, you know, this is like history repeating itself, right? When we started with what you were doing back in 2001 and fixing problems and what you were explaining, you seem to be like just doing it all over again now, isn't it?
It's sort of that again, yeah. It's
but more complicated. This is 10 times more harder now.
It is compared, but we have many more sophisticated tools and fast computers that we can accomplish all of this pretty seamlessly. So anyway, that's that part of the thing. And if anyone wants to take note, if there's any questions, please reach out to myself and Brandon. What I'm going to do is drop this screen share and go to, just to show you some quick examples on my other computer here. Let me just give me a minute here so I get there. There we are. Share. So, okay, there we are. So here is basically, you know, we were asking, let me just get back here, get the right thing forward on my screen. There we are. Okay. So, you know, I could spend hours on this, but this is just showing typically what's going on behind the scene. That here we have an area image, we're deburring it, it's an ARR file. We have the IDT, which is taking it into the Colorfront working space, and then we have a look library. where we have a whole list of different looks that are available, film looks, synthetic looks. In fact, we can have in this system 3 of them, and a lot of systems 2 of them, and blend between them and alter them. So, and then the all essential part that we were talking about is this here, which is the output transform, which basically we can set what color space the display has, what the curve is, whether it's in this case it's gamma 2.4 since we're just doing SDR, and what the brightness level is going to be. And we have some overrides that if you're in a here, I'll show you that. If we're in a bright environment, we can override this with an adaptation that gives you the same perceptual look for a bright environment, as well as if we're in a really dark environment. This is making sure you have the same perceptual look. And then we can alter the transform characteristics going to display, where we favor a brighter image with more highlight roll off or less. And this is really great. If you're an SDR, you could, and you wanted to trim it that window, if we could see in HDR, we'd see it be really bright and it might distract from the girl. Instead of doing windows around it, we can just bring this control down for the HDR, if you were to do a trim, just to bring it down so it wouldn't be so bright. Also, if you'd had this out on set and you were using this, the preview and seeing in HDR, you would probably just light accordingly and balance things. I can get into a whole thing about HDR lighting and some of the, things you run into in doing that. So basically, we've got several implementations. And so here is just the full node-based. We have one.
Bill, and what is the system that you're using at the moment again? Are you on?
So we're on Colorfront transcoder. So just this is a mastering software, and also it could be used for look development, making the CFE files, publishing LUTs, even publishing as you saw in the other diagram. You can publish the common LUT for ACES common LUT format that you can plug in as a fixed transform to any of the other ACES workflows and some other products.
I just have to read one comment, and you're going to love this one. Jay-Z is with us.
Oh, hey, Jay-Z.
And he said, Bill is amazing, 3 exclamation mark. I think, man, I love it. I love it. It's also nice to see that, you were working with Jay-Z. I think brought him to eFilm.
Well, Jay-Z and I worked on everything I've been talking about. We were working shoulder to shoulder over a good part of that history at eFilm. And so he has a very good appreciation of that. So that's very, very good.
I love it. I love it. This is just unbelievable. So basically, transcoder is not really used for grading, isn't it? You don't really intend it as a grading system?
We are, that's a very good question. We get pushed by a lot of people. Well, why don't you develop a modern color corrector and stuff? And we very well could, but we don't feel that's the best utilization of our talents. We feel that there's good products out there. And certainly if you augment Resolve, it does a wonderful amount of things. And we think that the plugin type of thing to augment the other products is the way to go, as opposed to try to compete neck to neck with them, because there's so many more other aspects of a color correction system beyond just the color management that need to be done. So basically, we have this plugin, and it puts Resolve on steroids. You can use all the wonderful Resolve tools plus the Colorfront, or you can put it in as a LMT, a parametric LMT in the ACES pipe. But here I wanted just to show you that here is one implementation. Here is the one with the CFE, which is just showing this simulates the plugin, or what's in POM4, what's in the FSHDR. And then here is the ACES pipeline, and basically it's the same thing. We come to ARRI raw, we're using the IDT to go to linear AP0, which is the ACES thing, and then we come out. If we look at the LMT, we have normal CDL values, which is really, really good. And that's the way people have worked with ACES. But we also allow you to choose, well, what color space are we going to apply the corrections? So that's part of it. And in fact, if someone wants some details on this, I don't want to spend too much time on it, but basically it's there, and we can turn it, you can turn it off and turn it on, and you know, you'll see the, you know, the differences on the image. If I go to, here is, so basically all three of these, if I go back and punch through them, all three of these match. So it's just showing that, so there's the full node-based one, here's the CFE that's implemented in all the plugins, and here's the ACES plugin. So basically, the look holds through all of it. I have one last slide here to show you, just to show you sometimes the importance of having this transform, you know, of having this. And here is just, this is a thing that's really plagued a lot of people. This is just a stock, you know, the stock ACES path with no CDL or any grading on it, but at the same, that's well exposed, so it falls in. But we see all the problems with colors going way out of gamut. If I expand the vector scope here over the image, so I think you can all see that, we see here that, oh, everything, all these colors in here are all blocked up and everything. And this is caused by synthetic lighting, with cameras putting colors out that go way beyond what any display can do. But if we properly handle those colors and remap them, we get back an image.
Wait. You have to show me this one more time. Because, you know, you don't know how many times, you know, we have these problems, you know. And I worked on a really big Warner Brothers movie once, and we ended up shooting in Singapore, a scene. And the Singapore's covered with these blue LED lights, and everything. We were doing ACES job, and everything was looking exactly like, what did you do? Show me, what did you do?
Okay, so this is just the default ACES with the current RRT ODT, and this is a Rec 709 ODT applied to it. And you can see, you know, a number of problem areas. You can see here that this is a glob of blue, because the blue in the camera goes way beyond what the display could do. So it's just hard clipped, and we have to somehow decide, well, the camera's actually seeing all the colors. How do we remap these colors? You can see what's happening with the splash on the ceiling. That looks really bad. You can see all of the purple and the problems. And just by simply turning on the LMT, which is, they would look the same if I applied the normal Colorfront engine to it, but this is just within an ACES path. You see that then we pull back all these colors and properly map them into, in this case, the smaller space of Rec 709.
LMT? Where can you show me the node tree, the LMT?
Yeah, so the LMT is right here. So we're, you know, we got the ID.
What did you do inside that LMT to map those out of?
Well, we turned on the Colorfront. So it's really, it gets put into our perceptual space, and we're adding our Master Look Bright. We have a transform called Master Look Bright, which basically matches identically what the default, as you see here, ACES transform is. So the black and white or brightness levels match exactly, but the colors are remapped to fit properly into the color volume that's being delivered. So if we delivered this into a display that could do P3, we'd get a little more saturation up here, maybe in the cyan areas, but you wouldn't see a big difference, but it would still look correct, because even on a Rec, if you had such a display like a Rec 2020 display, these colors coming from the camera go way beyond that. So properly mapping them back in, you know, trying to do this with color correction, you could spend hours.
No, you can't. The problem is, like, you need to do it like even before it goes through the whole RDT stuff, because you know, it's just very, very hard. And
well, we're still going through,
you know, that
we're still going through the stock IDT into ACES, you know, linear and AP0 primaries, which actually, when you look at those coming from this shot, that actually puts out it's actually out of gamut to the AP0 primaries. But if you properly handle the negative values, you pull everything back in. So that's okay. A very interesting
and can I ask you something? So how come it's so selective that it only remaps colors that are out of gamut and not the whole gamut? You know, like, because,
well, it's it basically follows those colors that are improper, and it puts them into our perceptual model. It does two things. It doesn't just cut them off as this is happening here, where it just slices colors off. It maintains the full volume, and then going through our perceptual model, we say, well, we only have this gamut to work with. How do we remap these colors so that they produce as close to what the original color is, and look the same to the eye? So that's the reason you see these real extreme colors fall back in and get pulled in to where they belong. There have been attempts of putting out LUTs and things to try to deal with some of this, where you just desaturate, say, the blue axis.
Yeah, because you didn't do it selectively. It basically is smart enough to understand the stuff that's...
This is a complex mapping algorithm, but once again, it's not just based on, okay, let's look at it mathematically. We have to look at it on how it behaves with the way our eyes see things, and if we apply that attribute to it, and then things fall into place. And
so there is one question I just saw, like on the chat. You know, tonight, do you mind if I just ask a couple of questions, because it's an interesting...
Sure. This is a good time for it. Yeah.
Luckily, Bruno is in chat, so he's been covering a lot of the issues, so we didn't have to really stop. Bruno, thanks a lot for doing that. I really wanted to ask something like this now. So basically, you could then work in ACES and use your LMT as a basically inside an ACES pipeline, effectively, isn't it?
Yeah.
So it's I can switch between, you know, one another. And is this anything, you know, to do now with this announcement you made for 1.2 ACES with a parametric LMT? Is this what you're showing us right now?
Yes, that's what this is. It's the parametric LMT. And in fact, if some other platform doesn't support, say, the Colorfront OFX plugin, which gives you the parametric LMT, as I said, is that we can publish from this LMT node here. It can publish a common LUT format, CLF ACES LUT, so to speak, format. And if just for those who don't know what that is, it's a complex file that includes 3D transforms, matrix transforms, level transforms, 1D mathematical transforms. In any event, we can translate the Colorfront engine into that kind of a transform. And then that can, in any platform that supports the modern, the 1.2 LMT common LUT format, then it just plugs in, goes into the AP1 working color space, linear color space as it's supposed to, and there you are. So I published
this is huge, man. This is huge. This is unbelievable. And it means also, like, you know, that you know, I just also wonder, like, how we're gonna plug, you know, but with that LMT 1.2 ACES, we can then plug it into Baselight and whatever else, because, you know, hopefully everyone's going to be supporting it very soon.
Yes.
Bill, do you mind if I ask now a question to Brandon now? You know,
yes, I think this is good. Yes, Brandon has more interesting things to show you. How,
you know, Brandon is kind of, you know, Colorfront's new kid on the block, I'd say. You know, like, and he comes, I think originally you were at Apple, weren't you, Brandon?
I was at Apple for a couple years before joining Colorfront.
Yeah, so, you know, so he's like, I wondered, you know, what I have been asked, you know, so many times, you know, by my clients, and I think I could be a millionaire by now, you know, just counting the amount, if I had $1 every time someone asked me that question. And I'm going to ask you that question, and hopefully you're going to have the answer for that question. Okay. How can I grade at home and stream HDR to my clients without them having to have, you know, some expensive boxes and stuff being sent to them? Is there any way I could just open my grading system and get my client to open some sort of software and be able to see HDR live stream from my, you know, well, this is my daughter's room where I am right now. Do you think that would be possible?
Yeah, as a matter of fact, one of the things that...
it's not. I used to say no. I know, I kind of... But you say yes.
People say no. We say yes. At least we try. So, you know, Colorfront's been in the cloud for a couple of years now. Actually, more than a couple. But you know, we were working on streaming technology for about the last 18 months before COVID set the world on fire. I'll share my screen really quick to kind of go over some slides that we have.
Bill, do you mind just quickly just stop your sharing? I think that we can
Let me do that. I'm sorry about that. Yes.
No worries. So I think, Brandon can
There
grab
we
it.
are.
Perfect. Thank you so much.
Yeah.
So, what I'm gonna, kind of go over in these slides really quick, because I know it's been just over an hour, so I want to get everybody through it all, is we've created a high performance, secure, and interactive transcoder and QC player that's supported in AWS and Azure. And what this allows our end users to do inside transcoder with their finished material, or now dailies as well, is play back a professional reference quality video from the cloud or from your facility. It could also be done with your machines inside your facility to a remote location. And then on your remote location, whether it's at Dado's house in his daughter's room, or at my office where I'm currently located in Santa Monica, out of an SDI card, either AJA or Blackmagic, to your reference display, like an HX310, or in your home, if you're not going to deploy a $30,000 monitor to your house, you can also use something like an LG C9, and you can also monitor in HDR. And as of yesterday, you can actually trigger and drive the LG display with Dolby Vision in real time from your mastered material.
So that's a tunneling, right? This is Dolby Vision
tunneling. Yes.
Wow. And but do I need the AJA card for that, and can I do tunneling on Blackmagic as well?
Both are supported.
Wow.
So on the slide, it has, obviously direct support from S3 storage. We can play back IMFs, DCPs, ProRes, Sony Venice, Red, Airy Raw, all those in real time. So it's not just a finishing mastering program or solution. It's also can be used for doing dailies as that starts to move towards the cloud in the world. And so for
so can I just ask you, because I didn't quite got that. So this is not the full transcoder I need. I can just have a QC player for that, right?
Yes. Yeah. So we have the full transcoder or OSD that's on your facility or in the cloud. But as a remote user, to answer your question, Michael, it's a YUV or RGB. You can do both. Both are supported. But here's a quick little drawing, and then I'll show you the streaming player of kind of an idea of what it does. Is basically in the cloud or in your facility, you have your database server, your computer, that over a secure connection to your remote location, you can connect to a lighter weight playback device, such as an HP ZBook or an HP Z2 computer that will control the remote system for playing everything back. But what I'll do now is I'll stop this share and I'll share the actual streaming player app. So this is the streaming player app, that the end user would use. So your client, your receiver side.
And how I can just send them the app and they can install it. They don't have to need an engineer visiting their house, right?
It's all self-installed. There are some requirements on the CPU side for the technology that we use, which is SRT for the encoding of the stream. And
it works on Mac and PC?
It works on Mac and PC as well.
Wow. Perfect.
And so what you're looking at here is the streaming player. And just real quick, so on the bottom left-hand side, that a little bit of Dado's logos covering are some of the icon systems that tells you what's kind of going on. One is for your rest control, so you can play, stop the remote server. You've got your encryption, you've got your bandwidth, and you've got your monitor connection on the bottom. You've got time code, which is frame accurate, from the remote control. And then you've got your play, stop, volume knobs, and your various settings. So I can come in and here's my performance. It's telling me what I'm doing. I'm remote connected. I didn't secure this this stream because I'm just doing testing, but it gives you all the feedback of what's actually happening in the live stream. And then I can come back here and I can see it playing back. It's a little jumpy on Zoom, sorry, but to show you that we are not tricking you guys and just using a streaming player app in some way, I'll stop my share and then I'll really quickly turn around And here I am in my facility. Let me turn the light off really quick.
And what, Brandon?
I
Show 'em
love
what you
this,
have.
man.
Yeah.
I
So
love it.
what we're looking at here is on our left-hand side. Sorry for the bright desktop display.
No, we can see very well. All good, all good.
So you've got your HX310 across the top. Just to show I'm not faking it, the time code is actually moving. It's frame accurate. If I was to pause it, it would match exactly what's happening on the system in the cloud. And then I'll go back, and then in addition to streaming the GUI control, so I can actually control my transcoder with a program called Nice, I also am able to stream my second head analyzer that's in the cloud. So I'm actually at the same time processing the file that's in the cloud and sending that signal to my desktop. So I'm actually looking at the file before it's encoded in the SRT profile, and then playing back in real time at reference quality with up to currently up to 8 channels of audio and 16 channels of audio coming soon.
So this is basically like a remote QC. Like we could get a QC guys to stay home and do the QC for the AWS server.
Yes, that's exactly the idea.
Or all the mastering also. I mean, this could be in the transcoder, and you're setting up to do all your deliveries, and you can have a reference quality view into checking your deliveries, and then launch transcoder in the cloud and the render node, and this could start crunching. So
wow, this
is that's a really quick demo of the Cloud Player and what we've been working on for a while, and been
so basically what and I can pipe just an SDI. How do I send signal from my room? I didn't get that. So what do I do? How do I send an SDI? I need to have a decode on my end first, isn't it?
Yes. So on the encoder side, or the server side, you have your computer that is going to encode the signal into an SRT stream. Which is an HEVC 444 RGB 10-bit signal.
Wait. 444 10-bit stream.
Yep.
So HDR is no problem, really, isn't it?
Yeah, HDR is not a problem. You can change the megabits per second. HD supported, 2K, UHD, and full 4K are supported in this stream. You can change the megabits per second from anywhere from 10 megabits a second to over 400 megabytes a second.
If you have
just for reference, well, just for reference, 35 to 40 megabits per second is visually lossless, so it can be used for QC. So you don't necessarily need to go to 400.
That's for 4K too.
And that's for 4K. Yeah. Wow. So in our office, we have a dedicated 1 gig line. So yes, I can go pretty high, but typically we're staying between 30 to 50 megabits per second. Then that's using SRT from Haivision. That's coming over the internet or public or private net, if you have that in a facility, to your home. Then your home computer will take the SRT stream on CPU and decode it, and then decode it on the fly, push it out your SDI card, whether it's a Blackmagic or an AJA card, to whatever display you currently have connected.
Beautiful. This is beautiful. This is also very elegant, because, we deal sometimes, like with people that don't really technical, and sometimes there are solutions that require like a dedicated hardware and a lot of bandwidth, by the way, because they're using JPEG 2000, whatever it is, right? So it's a more effort to get that box, an engineer, and the screen installed than the actual session where we do the review. You understand? There's more work for me and then I'm going like, why are we doing this? Why are we actually setting up this remote viewing for like a session that it takes longer? It takes 2-3 days just to organize for this box to do it. So right now what we could do is we could just tell them, here you go, just install this software. And if you don't want to have an SDI, that's fine. You can just watch it full screen on your display. But if you want a HDR, here is a PCI Express extender box or something like that, AJA or Blackmagic card that's gonna then pipe that signal through HDMI to your LG that you normally watch your Netflix with anyway. And that could be a great way how to get director or a showrunner to see the real kind of grade before it has been signed off and sent to actually distribution.
Exactly, and that's the idea. The idea is we didn't want it to be
and is anybody using that at the moment? Who's using that at the moment?
Currently, we have about 10 to 12 different companies that we're not at liberty to say who they are.
No, I get it, but it's been in use. It's not like this is not like a tech demo, right? This is being used.
Yeah, there are people that are using it actively right now.
Wow. Well done. I'm impressed. I mean, this is just amazing, man. And you know, like on top of everything, like, you know, I thought like, okay, this whole color science was amazing, but now that I saw this streaming, I just think like this is just unbelievable, you know. And I have to say, I remember years ago when I started looking into this whole cloud computing, I had to like work with my client trying to kind of reduce some of the costs for dailies, and I was really adamant that cloud's going to be the way to do it. You were the only person that actually offered me to run transcoding in the cloud. I remember you were the only company.
Yeah, we've been in the cloud, I think, for Bruno could probably correct me in the chat, but 4 to 5 years at this point, pretty solid with rendering. We have lots of customers that use our engine in the cloud to automate and streamline their VFX pull systems, and that's not new technology to Colorfront. That's just continuously evolving, you know, as this new world of working kind of moves forward.
And by the way, we have a John Darrow with us from Warner Brothers. Hey, John, how is it going? And he's asking how many $sign. Do we know that?
Well, the streaming player is included in Transcoder 2020.
So you can do it, John. You have it. You can do it.
And there's Bruno's correction. 6 years is what Bruno says. So we've been in the cloud for 6 years. Yeah, it's included in all of our Windows platform.
I love it. I love it. Guys, this was absolutely fantastic. And you know, for everybody else, you heard it on Colorist Meetup first. So just, you know, this was always my mission to give you the latest and the best news. And you heard it here first, right? I absolutely love what you're doing. This is just so good. You know, like it's just a kind of, it gives me like such an optimistic view on the future when I see like, you know, that actually some of those problems we had have already been solved and it's possible to do it. I can't congratulate enough, really. Like, you know, I have to say that this was probably one of the most exciting presentations we had so far, really, because it was just so beautiful. Bill, I want to just repeat, any day you decide to teach the world about, you know, some, at least small part of your color science knowledge, please find me, because I would love, you know, to kind of help you get some of that, you know, fantastic knowledge you have out, because I think what you're doing is unique and it's absolutely important. It's the right direction we need to take as an industry. Guys, if you want to hit, you know, Brandon or Bill, like, you know, with any questions afterwards, please do so. Maybe just, you know, post in the chat now, like a quickly email or, you know, like and stuff like that so that you can.
Yeah, we're pretty easy. It's just Brandon at Colorfront and Bill at Colorfront. Cool. So just, you know, first names at colorfront.com and, you know, even Bruno, I'll give his email address out. Bruno at colorfront.com.
Bruno at Colorfront. And I think you know, probably like, I think it's best, you know, for anybody who wants to have more questions really to take, you know, like a little bit more on a one-to-one level. I really hope that when this DaVinci plugin is ready, we're going to do this again. And it seems like we're going to have more surprises coming as well, because what you're doing is just absolutely amazing. So thank you so much. You know, thank you in front of all of us.
Yeah, thank you for having us.
Thank you for having us. It's been a pleasure. In, you know, like we all hundreds and hundreds of colorists and people who are dialing in. You know, we're a very small group, but very good one. I think we had amazing people here. I just saw, like, you know, from everyone who was dialing in, it was such a fantastic group. Guys, you know, if you're not kind of going to dive into this meetup, we want to be doing it. So it's a great encouragement to see you all here. Give us a thumbs up if you liked what you saw. You can share this link on YouTube for anybody that you know who hasn't necessarily seen it and you think it would be benefiting them. The reason why we're doing it is really to get the word out to the right people in the industry who really need to know about what's happening and what's possible. On that note, I wish you wonderful rest of the day, rest of the evening, or, you know, if it's in India, probably morning, you know, enjoy. And, you know, it's the future is going to be, you know, good. Seems like it, at least, you know, when Colorfront's in question. Thank you so much. See you soon. Guys, thank you. Thank you.
Bye.
Bye. Bye-bye.